Today we are going to make an exercise about Stoke's theorem in magnetism. The magnetic field intensity is given in a certain region of space, and this is the equation of the magnetic field intensity. We need to find the total current passing through the surface in z equal 2, and within these limits in x and y, in the az direction. And we need to show that the same result is obtained using the other side of Stokes' theorem. This is the formula that we're going to use to find the intensity. This is the left side of the formula and the right side, and we're going to begin using the right side of the formula. We need J, and this is the equation to get J. We're going to follow all these steps so we can get J and ds. First, we're going to see our equation with respect to z, that is this part, and we're going to derive it with respect to y. And we're going to follow that step throughout this formula. So this is our equation that we're going to get to find J, and we need to derive each part with respect to what they say here. And after derivating, we have minus 4 over y squared in direction to x, minus x squared plus 3j over z squared in direction to y, and minus 3 over z with respect to z. And this is our y. So now our equation says that I is equal to the double integral of y times ds. We already have y, but we need to find the ds. The problem is saying that we need the az direction, so our dx is going to be dx dy in the az direction. And so our equation finally is like this. This is our equation to find the intensity, and the limits that we're going to put on the integrals are going to be the limits that the problem is giving us here in x and y, because we need this z direction. Here the ds is going to be the dot product, but we don't have a ax or a y direction, so these ones go to 0, and we only end up with this. So minus 3 over z double integral from 1 to 3 and from 0 to 6. These limits are the ones given here. First, from 1 to 3 and from 0 to 6, dx dy. And then we substitute z with the 2 that they give us. So the integral of this is 12. And our final answer is minus 18 amperes. We already did the right side of the equation, and we are going to comprovate our result and demonstrate that it is the same. We are gonna be using this equation h dot product dl. This is a line integral. We need to draw or sketch the points that they are giving us to get the directions of the x, the y, and the z. And this is a line integral, so we need to make 4 of this. Now we have here our Cartesian plane, and we need to draw these limits inside of here. So here is telling us that x is bigger or equal to 0, but lesser or equal to 6. So this is my x, y, and my z. So it is very important to draw arrows to see the direction. Now we can get our dls from each line integral. This is going to be dl1, that is this arrow, and we're going to take it as positive, so dx in the x direction. Same with y. And here on the third dl, this is against the one that we just draw, so it's going to be a negative dx in the ax direction. And this is the same with the fourth DL is going to be a negative because it goes against the one that we just draw. Now with the data that we just got, we can start making our line integrals. This is the first integral that we just got, and uh, this goes to 0 because we only have the x, and we have here that this part goes to the x direction, so it stays. In the second integral, it's going to be the same j that we had already, and but this is going to be from dy to the ay direction plus our third integral, and this is going to be minus dx to the ax direction because it's the one that goes opposite to the first one. And for example, in the second one, we can put this to 0 because we have in direction to x, and we don't have here direction to x. And this one direction to z, and we don't have here direction to z, so it goes to 0. And on the third one, we have direction to x, so this part stays, and this part goes to 0. And finally, on the last integral, both parts can go to 0 because we have a x, a z, and we only have a y here, so both parts go to 0. So at the end, we end up with these two line integrals that are this one, this part, and this part, because everything else went to 0. So we're going to evaluate, because it is dx and minus dx, we're going to evaluate from 0 to 6. Ah, por los límites, ¿no? En unos vale 3 y en otro vale 1. Ahorita le digo. These are our integrals already evaluated, and the value that we are going to substitute here in the y, it's depending of the value that we have here. For example, on the first one, the first integral, y is equal to 1, and on the second one, because it was the negative, y is equal to 3. And at the end, with everything evaluated in the in the limits that they corresponded, we have our final result minus 18 amperes that we already demonstrate that was the same result as the first one. Thank you. Dura demasiado.